another video dealing with circular permutations in our series of videos covering permutations and different types of permutations and combinations. Let's take the case of three distinctly colored marbles, that's green, blue and red. So how many ways can these three marbles be permutated or arranged? Naturally, we know that something which we have discussed in detail in our first video dealing with the explaining the theory of permutations. For three distinct objects, we can do it in six or three factorial ways. Now, a very important thing is that even though it's not obviously stated, when we do a permutation, it's considered that we are dealing with a permutation or arrangement as if it's done on a straight line or as if it is done in a straight manner. So in this particular case of three distinctly colored marbles, it will be green, blue, red, green, red, blue, then going on, blue coming first, that is blue, green, red and blue, red, green, and of course red, blue, green and red, green, blue. So six ways of arranging these marbles. Now what if these three colored marbles are kept around a circle and are kept in a circular fashion? Naturally, circular fashion means that the way in which we count or the way in which we arrange or permutate obviously will have two directions, that is clockwise or anti-clockwise. So let's do it first. Let's do the arrangement in a clockwise direction. And let's start with the green marble. So we can see that green, blue, red, green and red, green, blue. So that's the way that's the way in clockwise when we start with green. Now let's do it in the opposite direction, that is anti-clockwise manner. Again, starting with green, it will be green, red, blue, green and blue, green, red. Again, now we can see that three ways of arranging them in the arranging the three marbles in the anti-clockwise fashion. Now the point here is not a very important point, that we reached the three. The permutations were three, or the permutations or arrangements were three, because we took we did it from a particular object. Otherwise, circular permutations basically would be, in this particular case, basically would be dealing with a single permutation if such a thing was not done. That is in circular permutation, the difference is from where we start the counting. In this particular case, we started from green. If that's not the case, it will always end up as a single circular permutation. Of course, there's the difference of clockwise and anti-clockwise manner. So let's look at the formula for a circular permutation. And naturally, we are first taking the clockwise direction. So for clockwise direction for three distant marbles, it's n factorial by n, that is n minus 1 factorial times n by n, cancelling out the n, we get n minus 1 factorial. So that's the formula for a circular permutation in a particular direction. And here we have three distant objects, so n is 3. So the number of permutations is 3 minus 1 factorial, that is 2. That is two permutations, two ways of arranging the marbles. Now the interesting question is how we are getting this two ways. How come we are having two ways of arranging the marbles? Basically, that difference is coming from the fact that we are dealing with distant objects, and also because that 2 is coming from the clockwise and the anti-clockwise manner. Here we are basically dealing with three distinct objects, that's three differently colored marbles, and of course when such n distinct objects are arranged in circular permutation, the most important thing is the direction in which the arrangement is done, that's whether it's clockwise or anti-clockwise, and that determines the number of permutations done. Naturally, in this particular case, in the example we are dealing with, as the colors are distant, which means as the marbles are distant, there are only two ways of permutation possible, that is anti-clockwise and clockwise. Now, a very important thing which is absolutely essential in doing problems dealing with circular permutations is that from which object we are doing the permutation. In the particular case which we are discussing, we chose the green marble, and it was from the green marble the permutation or the arrangement was decided. It isn't necessary that it should be the green marble. We can choose the other two marbles, either of the other two marbles also. So not the point that we are keeping a particular object. In the particular case which we discussed, we kept the green marble as a reference point, as a starting point, and the permutations both clockwise and anti-clockwise was done from there. That is, was done with the green marble as the starting point. So that is very important when we solve problems, when we solve different problems dealing with circular permutation. That is, from which object are you taking the permutation. So as I already stated, let's look at the formula once again. Here more directly with taking the permutation equation, that is for n objects, not the point, the objects are distant, that is each one has characters which are distant from the other one. So for n objects each distant, the number of permutations possible in circular permutations, of course, is n minus 1 factorial, which can also be written as npr by r. And npr, not here, we took n as equal to r, so it will be npn by n, that will be n factorial by n minus n factorial by n, and of course n minus 1 factorial is equal to 0 factorial, which of course is equal to 1, which means that it will be n factorial by n, and that of course is n minus 1 factorial times n by n. Cancelling out the n, we'll be getting the obvious equation, that is n minus 1 factorial. So what about the second case where the objects are not distant? I mean, the theory and the example which we just did were dealing with distant objects, and what if the objects are not distant? Something like the beads on a necklace, or the diamonds on a necklace, where all the constituents look the same. So what if the permutation is something like that? So in the case of marbles, we took, now what if all the marbles are colored? For example, or if the marbles, all the three marbles are colored red? It basically means that there's no way we can differentiate between the first, second, and third marbles, which simply means that in this particular case, the clockwise and anti-clockwise distinctions won't be possible. So it can be easily see that in such a case, the clockwise and anti-clockwise permutations, that difference won't be possible, or both end up being the same kind of permutation, which simply means that in the equation which we just did, we'll have to divide in the formula we'll have to divide the formula by 2, that is. So in such a case, the equation will be the possible permutations will be n minus 1 factorial by 2. So it will be n minus 1 factorial by 2, which of course can be written as NPR by 2R. Now let's look at some interesting examples to get a fairer and clearer idea about circular permutations. And only when we do problems, we'll get a finer idea about how we should be applying the concept. So first, we are dealing with a case of 10 students who are sitting around a round table, and what are the how many ways can you seat those 10 students? That's what we are looking at. So seating 10 students around a round table, how many ways can this be done? Of course, 10 students basically means 10 distant. Of course, we are dealing with each student is different from the other student. That means we are dealing with distant objects, which basically means that the answer would be n minus 1 factorial. So it's n is 10, so it will be 10 minus 1 factorial. That will be 9 factorial. So here the answer will be 9 factorial. And let's bring in an interesting twist here. Suppose to seat this 10 students, there aren't enough seats. There aren't enough chairs. So what if there are only 9 chairs for these 10 students? Then it will be 10p9 by 9. That of course will be 10 factorial by 10 minus 9 factorial by 9. And that of course will be 10 factorial by 1 factorial by 9. And 1 factorial of course is 1. So it will be 10 factorial by 9. And that can be written as 8 factorial times 9 times 10 by 9. Cancelling 9 will be getting 8 factorial times 10 ways. Let's look at the case where till now we were dealing with distant objects. So let's look at the case where the objects are not distant. So suppose we are dealing with diamonds. Suppose we are dealing with 10 diamonds. All of them are of the same kind, and we are taking this particular diamonds to make a necklace. So how many ways can these diamonds be arranged to create a necklace? 10. So naturally, diamonds are considered, there's no indication in the problem that the diamond is each diamond is different from the other diamond, so the diamonds are considered as not being distant. So naturally the equation will be 10 minus 1 factorial by 2. So the number of permutations for a necklace where the constituents, in this particular case diamonds, don't have any distant property, of course will be, in this particular case it will be 10 minus 1 factorial by 2, that is 9 factorial by 2. Now let's bring in a simple twist. What if these 10 diamonds are having different shades, which means that something like a sparkling effect. One diamond is maybe like one diamond's sparkling effect, or one diamond's shades of color is quite different from the other diamond. Naturally, in this such a case, of course, we are dealing with distant objects. And what if we are looking at how many necklaces can be made where each one contains 5 diamonds? Then the equation would be 10p5 times 5. Note that if it was not dealing with if the problem was not dealing with different shades, which means that if the problem was dealing with diamonds of the same kind, then naturally it will be 10p5 times by 2 times 5. So this video dealing with circular permutations doesn't end. In fact, we'll be looking at another video dealing with the same subject. That second part of the video dealing with circular permutations, we'll be looking at cases, more interesting cases, which with more twists and applications in circular permutation. So the second part of this video, please watch it to see more interesting problems in this kind of permutation. And thanks for watching this video. And if you found the video interesting and useful, please like and subscribe. Thank you. And of course, thanks for watching the video.